giving a story about how we've invested in infrastructure, technology infrastructure, and leveraged it to save energy and optimize our processes. And although this is a mining application, I think a lot of the systems, the principles, the thinking, the vision is really transferable to any kind of heavy industrial process. So we'll start off just a little bit about Nickerum South Mine. We're located in Sudbury. Sudbury is about 4 hours northwest of Toronto in Ontario. And we're located in the historically rich mining area of the Sudbury Basin. And like any mine, there's two parts to a mine. Normally, everything that's on surface and everything that's underground. This is just a footprint of the mine, and it's all typical things that you'll see in any kind of industrial facility. We have a compressor house, and we have 4 hoists for moving material up to surface. We obviously ventilation. We have surface exhaust fans, administration and building. We have a backfill plant. You'll see over there. It's really just for filling in, transferring material underground to fill in the voids that you've created in the mining process. So those are all power consumers. And then underground, you'll see the ore body is there in the red colors on the right. Give you a bit of scale on what the scale actually looks like. But the kind of equipment you would have underground in a typical mine, they're all really listed there. We have a whole network of auxiliary fans, and they're really just circulating the air around to where it needs to be. We have a mobile diesel equipment fleet from dump trucks and drills, workshops. We have ore handling systems with conveyors and rock breakers, as well as dewatering pumps underground. Right? So that gives you an idea about the kind of equipment that's in there. And again, that's the same as you'll see in any other industrial facility. In terms of energy consumption, natural gas, diesel, but you can see by a long way, 80% of our energy consumption is electricity. And if you break that up, the pie chart on the right, 35% of that is really just for our surface ventilation fans. And then 17% is for underground equipment, most of which is actually ventilation equipment as well. So approaching 50% of our electricity consumption is actually in ventilation. And we'll talk a little bit more about the significance of that later. So there's a graph we put together on our what the future looks like as far as energy costs in Ontario. And not only is the curve going up, but you see in the black there's a huge amount of uncertainty in what the price is going to look like over the next 5 years. And it's really this more than anything else. That drives energy management right there, because it's very difficult to operate a business profitably and at all in that kind of scenario. So when we built Nickerum South, we really wanted to take the opportunity to say, what does a mine in the future look like in terms of energy consumption, optimization, ways of doing things better? And I think in the mining world, you find they're pretty good at running their surface metallurgical plants very much like any other, even similarly to how the chemical industry would run surface plants, smelters, concentrators, a lot of good automation, a lot of good control, a lot of information available. Hasn't historically been true for the actual mines themselves. So there's an opportunity for us to visualize a mine just as another process, really a muck factory. And just as we do on metallurgical plant, where we look at variability, and we look at optimization, and we can do the same thing in the mining world, and fully exploit the whole potential of automation. And the last point there is very important too, is just bring mobility to the actual industrial workplace. You know, mobile technology has changed the way the world works. It certainly, from a consumer perspective, has changed the way you and I live our lives. It's done that in the business world, but now's the time really to bring the advantages of mobile technology to the heavy industrial workplace. So what that vision looks like, and this is quite a busy slide, I don't intend to go through the whole thing, but what you've got there really are all the systems that make together a mine. So you've got bits of automation, some on surface. I don't think this pointer's working. Oh, there it is. Some of the stuff's on surface. The right-hand part's all the surface stuff. Everything's underground. You've got mobile equipment. You've got haulage trucks. You've got people walking around. You look at all those systems, and if you create an infrastructure that links both your surface and your underground facilities in terms of communication, then what you've done, you've changed the one thing about mining that makes it different to everything else, and that's the fact you have a surface, you have underground, and you have a few limited conduits between the two. There might be shafts, there might be ramps. One thing that makes it a little bit different to anywhere else. More difficult to manage logistically, communications, everything becomes a problem. But by creating this infrastructure, and it's a broadband communications infrastructure, now it doesn't matter so much where you are. The fact that that piece of mobile equipment is 2,000 meters underground doesn't really matter. And in fact, your OEM can dial into your system and do diagnostics on that vehicle potentially without being anywhere near it. And the same for myself. I have an extension at work. It doesn't matter where I am. You call me and I'll answer. Even if I'm 1,700 meters underground, I'll answer just the same as if I'm sitting in my office. So what does that look like? And this is just an example of one of our underground levels. This is our 1280 meter level. And we put in some wireless infrastructure and we surveyed it. And that drawing there looks very much like the kind of thing you'll see from a cellular network service provider. They give you maps and say, this is our coverage. Okay? And that's why I put this up, right? To get people thinking in that same kind of way. And what does that do to you or do for you? What it does, it becomes an enabler for all kinds of applications, many of which we haven't even thought of yet. I listed some of them there, and I'll talk about dynamic ventilation on demand. It's VOD. But this is an example of our tracking system that really just hooks onto that infrastructure, and every icon there stands for a different type of equipment, and you can see some of them are where some of our mobile equipment are, even where some of our personnel are. And we can start doing real-time production reporting because we can actually communicate to those pieces of equipment that are moving material underground. It's very useful even for mine rescue purposes. You have an emergency underground, you can see exactly where your equipment is and more importantly where your personnel are. This is an example of a scoop that you see on the right. That's a Caterpillar scoop actually. We now have access to real-time information that we never had before. Before, this kind of information was only available to the technician when the vehicle came into the workshop. He would plug in his laptop and maybe get some of this information. Right now, we can look, that's a histogram of fuel consumption on one particular vehicle. In real time, we can now see, well, is that normal or is it out of compliance? Some of the other information that you see there, it's a bit small, but we can now start looking on a shift-by-shift basis. Why are some shifts getting more utilization out of the equipment than others? For a typical shift A is actually getting this much truck time usage. Next shift isn't. Why? It's a training, whatever it is. And we can react much more quicker, whereas before we may not even have known that there was an issue. Ventilation demand. And this is, as I said earlier, one of our biggest consumers of electricity is in ventilation. So there's a lot of potential. If we can get our ventilation right, that's just directly going to affect our energy consumption. A little bit about how mines are ventilated. Certainly in Ontario, the amount that you ventilate a mine is determined by legislation. You have to provide 100 cubic feet per minute per brake horsepower of equipment that you operate. And that really determines, really for most mines, that's how much air you need to provide. And so systems are normally set to run at maximum. You know that you've got maybe 100,000 horsepower worth of equipment. That's how much air you need. You run it all the time. And typically, the systems are not even manipulated at times when you don't need the air. Your equipment's not running. There may not even be people in the mine, but the fans just keep on running. And what ventilation on demand will do, as the name really explains, it'll actually reduce the wastage by matching, in real time, the actual air supplied to the actual demand at the time. We'll talk a little bit more about that. But the objectives then of ventilation on demand are then to do, as I've just said, optimize the usage of the fresh air volume,